the session, for information, the session is being recorded. We are going to be talking about multi-stage financial problems. Multi-stage, okay? And what do we mean by multi-stage financial problems? We are talking about a situation where you have to solve the problem in stages, make critical decisions about how much money is involved, and also at various stages, how much money will be involved at various stages and in total. Okay? So we're going to be applying the methods that we use for the calculation of present values and the calculation of future values. But mostly in this particular situation, we're going to be looking at present values. And examples will be when you borrow money to, say, purchase a car, and the company gives you $10,000. How would the company loans you $10,000? How would they determine how much you should pay them every month on that car? Or if you purchase a big building for $100 million, if the company purchases a big building for $100 million, or $50 million, or $20 million, whatever it is, purchase the machinery for $10 million. And then the question becomes, if they borrow the money, how much money will they be paying every quarter, every month, every year in order to pay off the loan? But one critical thing we'll learn about here is how to use Excel to look at the various payments, how we determine how much money goes to principal, how much money goes to interest, and what the balance will be. And that is what essentially I would like to work on today, because many students simply get stuck in that kind of a problem. So I will pull up, I will talk about the process in general. Then I'm going to pull up a problem, and we're going to look at that problem and see how we are going to solve it. And I'll give you an example. I'll pull up one of your homework assignments, and I'm going to use it. Okay, somebody's coming in. Okay, so are you seeing my screen?
Yes,
Yes, Professor.
Okay, thank you very much. Okay, so now these are examples of multi-stage financial problems. I'm going to look at the problem, one of the problems that when I say multi-stage. Let's look at that problem that is numbered 4. Okay. Let's look at the problem that is numbered 4. I'm going to renumber this properly. Okay. It says, Jane plans to buy a house in 10 years. The house she dreams about costs about $150,000 today. The cost of houses increases at 2.5% per year. How much will the house cost in 10 years? So the whole idea here is you first of all find out how much the house will cost in 10 years. That is the first stage of your thinking. okay? Because we know houses appreciate in value. So the house is $150,000 today. How much would the house cost in 10 years? So you find out how much are you looking to spend 10 years from now? Now, Jane currently has $75,000 that she can invest to earn 3% interest over the next 10 years. How much would Jane accumulate from her investment of $75,000 in 10 years? So you also say to yourself, I have this money. I'm going to put it in the bank. And in 10 years, it will give me so much. I will have so much money. Okay. And as you are looking at these stages of the problem, you are asking yourself, what is the right method? Okay. The right method for the problem number A, how much will the house cost in 10 years, is a future value problem. Because what is the value 10 years from now? It's future. Okay. And so Jane currently has $75,000. If she puts it in a bank, how much will that money become in 10 years? It's a future value problem. Okay. Now remember that A and B are not talking about $75,000 per year. You are not talking about the future value of an annuity, but no, this is just $75,000 invested today, once, here. And in 10 years in the future, 10 years into the future, how much will it be? It's a future value problem. Okay. Now, how much additional money would Jane need in 10 years? So in a sense, what you're looking at, this house is going to cost $180,000, $165,000 in 10 years. And so my money will accumulate to $95,000 in 10 years. So you subtract the cost of the house in 10 years minus the amount of money you will accumulate in 10 years. And so that is how much money you're going to need. So now the next thing is to prepare an amortization table to pay off Jane's mortgage. So when you eventually borrow money, how much money are you going to be paying per month in order to pay off your mortgage? If you're going to borrow the money, and it says you're going to pay off the mortgage quarterly in 5 years. Well, I don't know whoever pays off a mortgage in 5 years. You must have a lot of money. But we're going to use 5 years. Okay. So the first thing that we're going to learn, we already know about how to do problem number one. We already know how to, we already know how to do problem number A, simple future value problem, where we already know how to do problem number B, it's another future value problem. What we don't know how to do is the amortization, okay? This amortization now is a present value problem of an annuity because now the company is gonna give you the money today. So that is a present value, okay? And so how much money are you gonna be paying into the future so that you pay off the mortgage in 5 years? I'm gonna take this same problem and modify it so that we would have some different values and you can apply that method for the solution of your problems, okay? So what we're gonna really focus on today is amortization, okay? It's amortization. So I'm going to take the same problem, modify it, and we'll talk about amortization. So what you do when you take a car note, the company gives you an amortization table or an amortization payment. Okay, so let us say you plan to buy a house in 5 years. So let's make it 5. Okay, the house is $120,000 today. Okay. And so the question is, how much will the house cost in 10 years? And I'm going to try to solve it here. And so In 5 years, the house will cost of house 5 years. Okay. So I'm going to mark this. Five years, it's a future value problem. The value problem. And so the cost, which is a V problem, future value of the house, is equal to 120,000 times 1.025 to the power to the power 5. Am I correct?
Yes.
All right. Okay. That will be equal to 120,000. And what is 1.025 to the power 5? Somebody give me the answer.
1.131.
All right. 1.1314. Okay. 1.1314. Okay. And so you multiply that. And we have 135,769. We're going to take it 135,769, 135,769. So that is how much the house will cost in 5 years. Okay. So that's easy. Okay, you have $55,000 today. Let's make it 55. And we are looking at over the next 5 years. Okay. So you have $75,000 that grows at 75 at $55,000 that grows at 3%. Okay. And so the investment has a future value equals 55,000 times 1.03 to the power 5 equals all right. So what is 1.03 to the power 5?
1.159.
1.15927. That is 55,000 and 1.1527. And that should be equal to how much?
63760.07.
Okay. You are correct. Okay, 63,759. So let's call it 63,760. 63,760. So that is how much money you would have accumulated, you have invested. So how much money you need? You would need 72,009. Okay. Okay. Need was 135,769 minus 63,760, which will give you how much money? 72,009. Okay. 72,009. So that is your need.
Oh, see. Okay, I got that. 921895.
Okay. So you will need 72,009. So now the question becomes, how are you going to pay off the loan? So prepare an amortization table to pay off Jane's mortgage. Okay. Let us say now you're going to borrow money at an annual rate of 6.5%. If you pay off the mortgage in quarterly installments in 5 years. Okay, let us assume that you are a wealthy person, that you make a lot of money. So you're going to be able to pay off your mortgage in 5 years. So how much money are you going to be able to pay off? I mean, how much money would you need to pay every quarter? Okay, so you realize here that your interest rate is going to be a quarterly interest. So let's go through that. Okay. So the interest rate will be 0.065 divided by 4, since you're paying off quarterly. Which is equal to 0.065 by 4 will be 0.01625.
625.
0.01625. So that's going to be your quarterly rate of interest. Okay. How many periods? How many periods are you going to be paying this thing off? Somebody tell me. Hello? How many quarters are there in 5 years?
20.
20. There'll be 20 quarters in 5 years. Okay. All right. So we're going to use now, remember the bank is going to give you 72,009. And you're going to be paying it off quarterly. And so this time you're going to ask yourself, they're going to give you the money today, the present. And so what is the amount of money that the bank is going to be receiving from you? Because now they're going to be receiving a fixed amount of money every quarter from you for the next 20 quarters. So you're going to be dealing with a present value problem. Because for the bank, they're giving you the money in the present. So how much money are they going to be receiving from you so as to be able to get their money in 20 quarters? Okay, so it's a present value problem. So the PV is equal to 72,009. Okay. So we're going to use PV is
72,009.
equals to 72,009,
So
which will
one,
now be equal to the equals to the periodic payment. So your periodic payment times PVIFA of 0.01, or you can say of 1.625%, 1.625% for 20 quarters. Okay, PVIFA. All right, and we know the formula for that. So let's put it up. 2,009 equal to your periodic payment. I'm just going to call it your payment times. I'm going to insert a formula. Okay, which is okay, minus 1.0 going to not write in the equation. Okay, so I'm going to make this bold. All right, so now you see the formula out there. 1 minus 1.01625 to the power minus 20. And so the question is, what is 1.0625 to the power minus 20? Okay, so we have okay, 72,009 is equal to payment, the periodic payment. Okay, so somebody tell me what is 1.0625 to the power minus 20?
0.72441.
Okay, very good. 1.06, 1.0, 625 to the power minus 20. Okay, 0.72442. Am I correct? Hello?
Yes, Professor.
I am correct. You are correct. Okay, you are correct. Okay, and so when you subtract that from 1, what do you get? One minus that, what do you get?
Minus 0.27558.
No, when you subtract 0.72,
0.72.
1 minus 0.7244 is what?
You get 0.2756.
Yes,
Yeah,
0.2755.
0.256.
Okay, so you have
Divided by.
what you have is 0.27558, 0.27558 divided by 0.01625. Am I correct?
Yes, yes.
All right. And so that implies that 72,009 is equal to the periodic payment equal to, and so 0.27558 divided by 0.01625. What is that?
It's 16.958.
Very good. Equal to payment times 16.9589. 16.9589. Okay. So now the question is, how much is your periodic payment? How much is your periodic payment?
It should be 4,246.13.
Okay, 16.9589. 4,246.09. Am I correct?
I
Hello?
got 0.13.
Yeah, fine.
So I got 4,246.13.
And 1.3. Is that correct? 4,000.
Yes, that's correct.
Okay. So equal to 4,246.13. So first of all, you can see you have a stage. Okay. The first stage is to calculate what your periodic payment will be. Is that correct? Are you following me?
Yes, we're following.
Okay. So you can see why we call it multi-stage. First of all, you ask yourself, how much will your house cost in 5 years? All right. And then how much would you be able to accumulate in savings in 5 years? So now you subtract the next stage. How much will I need? All right. Okay. So now what you need to do then is to ask yourself, can you demonstrate how this amount of money, if you paid it every quarter, it will pay off your loan in 5 years, in 20 quarters. So that is what we're going to do next. Okay? So I'm going to write down the periodic payment is 4,246.13. Your loan is 72,009. Write that down. And so what we're going to do next is we're going to now amortize this loan. Okay? We're going to amortize that loan. So I'm going to okay. So now we're going to do the amortization, which is, so I'm going to stop this share, and then how much would the interest on the loan be? Okay. You know what it is. The rate is 1.01625, and N is 20 quarters. The number of quarters is 20. So let us stop this share and pull up an Excel file and set it up. Okay. I'm going to start a new share. All right. So we have a new share. And so you will say the period. Okay. So the first period, you have only 20 periods. Okay. So you have your payment. And when you make the payment, the bank will deduct interest. And the rest will go to your principal. And this is how much you owe. Okay. So when you start the loan, you have 72,009. That's what you have. Okay. All right. So you start a loan. So every month you pay 4,246, 4246.13. That's how much you pay every quarter. It's constant. Okay. So we are solving for the present value of the periodic equal installments. So your interest is the amount of interest you pay equal to 0.01625 star L4. So you multiply by L4 because your balance is on L4. And so how much goes to your principal? When you pay 4,246, how much is credited to you? Because now the bank takes interest and then credits you with the balance. And the balance is equal to I5 minus J5 was I5 minus J5. Okay. So this is how much goes to your principal. Okay. You pay 4,246. The bank takes 1,170 for interest. The balance goes to your principal. And so the difference goes to your principal. And how much is your balance? Your balance is equal to L4 minus K4. Sorry. Minus K5. Okay. Your balance is what was there previously, the previous balance, and as the amount that is paid to the bank. And so, minus the amount that the bank takes as interest. And so now you have your new balance is 68,933. You see that? The bank takes interest. You pay this amount. I'm going to make it bigger. All right. You pay this amount. That's how much you pay. The bank takes that as interest. Okay. The bank takes 1,170 as interest. Okay. So 3,000 is credited to your principal. And your balance is your balance is 68,933. So the next period, I'm going to drag this down. can see in period 2, you pay the same amount of money. The bank takes a lesser amount for interest, and the bigger amount goes to paying off your loan. And so your balance is reduced. Okay. With that period, you pay the same amount as payment. The bank takes a lesser amount as interest. The bigger amount goes to pay off your loan, and you can see your balance is reduced. And you do this every quarter, and you go down. What happens at the end of 20 quarters? What happens at the end of 20 quarters is your loan is reduced to 0. And as a matter of fact, the bank will owe you $1.16. Usually what they do in America is they will send you a check for $1.16. Okay. Or they will reduce the amount of payment at the end. They'll send you a letter at the end, a month or two, that your last payment will be less by $8.16, which will be about $424 and change. Okay, so that is essentially how to do an amortization problem. Okay, and so having said that, does anybody have any questions? All right, I'm seeing somebody shaking their head, saying there's no question. All right, that's nice to hear. That's nice to see. That's nice to know. Whichever one is more appropriate. So it's nice having you around. If anybody still has a question, ask the question now, or that will be it. I'm going to post this for everybody to see, including the table.
Thank you so much.
All right. And that's essentially what you're going to see in all the other problems. You're going to see one kind of amortization problem or another, including, how much to invest. And you can also show it in a table like this. So long as you have the right formula, whether it's a future value problem or a present value problem, you can always show the accumulation, or you can show the amortization, which is, amortization simply means killing the loan. Okay, that's what amortization means. It means you kill the loan. If it's a future value problem, then you accumulate, you grow the investment. And you can show it in a table like this. You get it? All right, okay.
Yes,
Yeah, I got it. Thank you.
Thank you.
All right.